from any of a large number of processes that run as local system. It's quite extensible. It actually started life as a test harness, so that I could just sort of play with some of this GDI stuff. This is the main reason why I'm releasing it, because there's a lot of code in there that if you're curious about how GDI messages work, you want to play with them, maybe you've got a couple of ideas how to exploit them. Smashing's got a reasonable code base for you to start. Most of the routines that you'll want to use are in there already. Why is that turned off? Hello, PowerPoint. There we go. It's capable of brute forcing. It can brute force every window on the system, every window on the desktop, every process on the system, or every window that belongs to a specific process. So if you've got a particular process that you know is running as local system, you can just point smashing at that process, and it won't mess around with anything else. It'll just exploit that one issue. I'm a note ahead of myself. Window titles, they're great. I'll talk about them a little bit more later, but code injection by changing the caption of a window, essentially. There's a few caveats that you need to remember if you're going to do that, but that's the main way that smashing works. The other thing that it can do is it doesn't actually necessarily need a window on the desktop running as local system. What it needs is a thread on the current desktop which is implementing a message queue. It doesn't have to have any windows. As long as it's got a message queue, you can put messages in that queue, obviously, and it will honor them and it will handle them and you can exploit it. There's a number of threads that form WinLogon that have no windows but have message queues, and you can use smashing to exploit them. The way that it works, if I just show you the source code here. Anytime, Visual C. The way that it works is you can see this shell code. All this does is it runs smashing again. That's all it does. There's a function down here called makeexploit. What that does is it takes the current running process name and the full path, tacks it on the end, and that's the full shell code. So what happens is, if I can get back here. Once the shell code's been injected into your high privilege process and it's running another copy of smashing with high privileges, the two connect with a named pipe and pass parameters and all sorts of information, various things that you can specify on the command line, like the process that you want to execute, stuff like that. Makes the assembler shell code much simpler and much more versatile, much more possibilities that you can do with it. If the named pipe doesn't work, in some situations, the named pipe can be a privileged operation. It'll fail over to a named file, so it'll write all the parameters to the named file, and then the high privileged copy will open up the named file, read all the parameters, delete it. Once the high privileged instance of smashing has received all the parameters about what to start and how to start it, that's the process that's responsible for then executing whatever command it is that you want it to do. The brute forcing, there's a lot of people sent me a lot of emails saying, how can you reliably guess your callback address? You don't know where your shellcode is within the memory space of your target process, so you have to brute force it. Well, one thing that smashing does is it puts a pause between each WM timer message. The idea being, if you're brute forcing something like WinLogon, WinLogon uses structured exception handling. So if you get the address wrong, structured exception handling kicks in, deals with the problem, and WinLogon carries on executing. So you can send as many WM timers as you like, and as long as you put that small sleep between them, you're going to be within the limits of structured exception handling, and WinLogon's going to carry on. I haven't actually seen a blue screen from smashing in rather a long time. It stays well within the limits of SEH. Code injection through a message box. Smashing will pop up a message box which contains shellcode. I'll talk about this a little bit more later, but essentially you do not need to interact with the target process in any way. You can completely leave it alone, not change any captions, nothing like that. You can, I'll talk about this a little more on the next slide. I'll just give you a quick demo of smashing. Okay, I don't know if you can read that from there. All I'm doing is smashing /I. That tells smashing that I want to run cmd.exe, the final parameter, on the interactive desktop. It's perfectly capable of attacking any process on any desktop. You specify /I and it forces the default window station and the default desktop. So if you do that, it wanders through, finds WinLogon, finds the various windows that WinLogon has open, and it pops up a command prompt. That command prompt is running as local system, but I don't have who am I on here to prove it. So it's very simple. If you just run it, it's got all sorts of capabilities as well for enumeration. So if you're curious about what's going on, curious about what hidden windows are around, things like that, it's got all the capabilities in there. So have a play with it, hack it about, use it as a test bed for further exploration, if you like. Okay, coming back to these window titles, they are great. If you're doing anything with shatter attacks, window titles are superb. Let me explain why. In order to put shellcode into a window caption, you can either use the wm-set-text message or the set-window-text API call. They're essentially the same thing. Set-window-text actually sends wm-set-text. So you specify a string, and lo and behold, the caption of the target window changes. You have oodles of space for shellcode. You can easily put half a meg of shellcode into a window caption. So if you're brute forcing, you've got a half meg NOP sled followed by 200 bytes of shellcode. How efficient do you want your brute forcing to be? Shared heap segment. This is a performance enhancement that was added to Windows quite a while ago. Basic idea is, if you've got a process that wants to read information about another window on the desktop, the way that it used to work is it would jump into kernel mode. The kernel would then marshal all the data between the two processes, and it would come back up with the relevant information in the calling process. The way that it works now is there's an area of heap that's shared between all processes on the current window station, which contains all of the information about Windows, well, top-level Windows anyway, so all the captions, all of the locations, things like that. So what I can do is, if I pop up a message box in my process, if I put my shellcode into the window caption of that message box or window or whatever it is, that shellcode is automatically mapped into the address space of every other process on the current window station. So it's great. You know, half a meg of space in any process on the desktop. How much fun do you want to have? Oh, that's what I've just talked about. Unicode, it helps out lots. One of the biggest problems with writing shellcode is making it null byte free. Unicode, you do not have to worry about it. You can have 0 bytes. So you don't have to worry about stripping all the null bytes out of your shellcode. You just send, instead of post message, you do post message W, which specifies the Unicode version of that function. The string that you send is interpreted as Unicode, and it's just sent. If you have too many NOPs in a row, too many null bytes in a row, obviously it'll truncate the string, but if you've got the odd null byte here and there, it makes no difference. Unicode is really useful in this situation. The only downside to using window captions is that they are read-only. This shared heap area, if you are able to modify that at will, there might be consequences, so it's made read-only. This does mean that you can't have self-modifying, self-decrypting shellcode. Unless you do something clever like decrypt yourself onto the stack, something like that, allocate yourself some memory on the heap and then decrypt yourself into that and then jump to it. There's a lot of things that you can still do. Personally, I just make shellcode that doesn't self-decrypt. You can have null bytes anyway, so you don't really need to self-decrypt. Different ways of injecting code into another process. Edit boxes. The original Shatter paper used these. The method is still perfectly valid. You can still do it. Named pipes. If you can set up a named pipe to your target process, dump your shellcode into the named pipe, it ends up being handled by that process. Simple as that. Files, network streams, basically anything that you can do that gets data into your target process's address space, it's fine. You don't care where it is because you can keep hitting it with your messages until you hit the right shellcode. The only problem that you might have is how long it's there for, because what you're sending a shellcode probably isn't going to be a request as it's expecting. So the moment that the process realizes that there's something gone wrong, it's just going to release the memory that was allocated to it. So you have to be fairly quick. Something else that's worth mentioning is hook libraries. You can create a DLL which is mapped into every process that you own to allow you to hook API calls. Essentially, it's a very good, very reliable way of injecting shellcode at a known location into another process. A little bit awkward. It's not that simple to do. Certainly WM set text is much easier, but it's worth mentioning. Okay, so you've got your shellcode into your target process. How do you actually execute it? Well, there's two sort of classes of ways to do it. Direct execution is things like WM timer, where you supply a pointer in a message, and your target process will jump to the address that you specify in that pointer. You've got no messing about, you've got no problems. It just goes straight there. You can brute force it trivially, not a problem. Alternatively, you can manipulate the user interface of the target process in such a way as to cause a problem. So you might be able to cause a buffer overflow or a format string bug or something else, just because when that process reads back the contents of its own user interface, what it gets back, it's not expecting. So it's just another way to get unexpected input into a process. There's all sorts of possibilities that you can think of. Okay, direct code execution is very, very reliable. Def window proc is the sort of the default message handler for any process. It will just jump directly to the address that you specify in the message. No messing around. Some messages that do this: emset word break proc. Oliver Lavery released a paper through iDefense a month or two ago that publicized this. Essentially, you can take an edit box. You can set a word break procedure, so a procedure that's called when the window needs to figure out where the starts and ends of words are. So you send this message to an edit box or a multi-line edit box, and then you can either just fill it with text or double click. When you double click, it highlights a word and it calls your address. LVM sort items and LVM sort items EX, this is for list view controls. This is a sort function. So you say to the list view control, right, I want you to sort your contents. Here's the function that I want you to use to determine how it's going to be sorted. This is the message that the utility manager patch fixes, at least in utility manager. I'm going to be demoing some code for that in a sec as well. EM stream in and EM stream out, these are for edit boxes. They allow you to stream data from the edit box into some other mechanism. So you say to them, okay, take input from this function here, or take all of your contents line by line, however you want to do it, and put it in this function here. Call this function with that data as a parameter. So it's a callback function, not quite, but you can specify a pointer, and the application will happily jump to that. TVM sorts children's CB. This is for tree view controls. It's another sort function. Basically the same as LVM sort items, but just for a different control. So if you've got a tree view control, send the message, it jumps to the address. Hooks as well are worth mentioning. You can hook pretty much anything that you like within your privileged space. So set up a hook and the application will obligingly execute your code for you. Indirect execution. The idea is to corrupt the GUI in such a way as to cause a secondary exception. You can do it by adding a string to a list box. I've got a demo coming up in a sec that shows you this. If you've got a list view control, the multi-line column thing, you can insert an item into it. You can add a string to a combo box, anything. Essentially anything that application can do with its GUI, you can do programmatically from another process. And all the messages that you can send will normally be honored. Another one that's worth mentioning is emset handle. What this does is edit controls the way that you manipulate the memory that edit control uses to store its data is you get a handle to the memory, you then lock the handle, and you get a pointer, and you can do what you like with it. Well, there's a message emset handle that allows you to tell that edit control what memory handle to use to store its own data. So it might be exploitable, it might not. At the very least, the application gets extremely confused because it's lost half of itself. It's quite amusing to watch some of these applications just not know how to cope with what they're seeing and just fall over in fun and amusing ways. It is fun, trust me. Okay, let me give you a quick demonstration of indirect execution. If I run Notepad here, I don't think so. If you move into the middle, you might be better off. Okay, so we've got Notepad, probably one of the simplest applications on Windows 2000. Yeah?
I think there is a third kind of way to execute code.
There is. I'm going to... No, I'll talk about that in a second. Let me demo this first. Okay, Notepad, probably the simplest application that comes with Windows 2000. It's got a font dialog with a number of list boxes. Well, I've got some code here. Yeah, I did have some code. Right. All it does is it does a find window. So it retrieves a handle to the first window on the desktop that has the title font. So that's this font dialog here. It then enumerates all the child windows of that parent dialog. And the way that enum child windows works is you specify a callback function, and Windows will call your callback function once for each child window. So you get the handle, and you can do what you like with it. Well, what I'm doing here is I'm sending a message to each of these child windows saying, add a string to your list box. And that string is just a nice long bunch of A's. So all I'm doing is anything that's a list box will honor that and we'll add the string. Anything that's not a list box, we'll just ignore it. So before I run this, I'm just going to attach a debugger so you can see what's going on. Okay, so the debugger's running, and I'm going to run indirect. Okay, so it's found the dialog, it's enumerated the children, and it's told me that it was successful. And as you can see, there's now an extra string in that list box. Now, if I click on that string, it stops responding. Now, if I go to the debugger, you can see what's actually happened is we've jumped to 0061, 0061. Looks to me very much like a classic stack-based buffer overflow. We've overly long string, overwritten the saved return address, returned to it. Now, unfortunately, this is Unicode. So 0061, 0061, we can probably exploit that if we wanted to. I mean, it's Notepad, so whatever. Proof of concept more than anything else. But it's a Unicode address. How can we get around that? Well, if I restart Notepad, I can show you. All right, I'll reattach the debugger. Now, do you remember I mentioned the way that you can explicitly specify a Unicode function and Unicode parameters by, instead of doing send message, you do send message W? Well, I happen to have compiled the exact same code as this, but using send message W instead of send message. So if I run indirect W, it does exactly the same thing, but you can see that the string that it adds is not A's, because it's treated the string that I've provided as 2-byte ASCII characters. So whatever, 2-byte Unicode characters. So whatever that character is, it corresponds to 6161 in Unicode. And if I click on that now, again, the debugger fires, and you can see I've got complete control of EIP. I can do what I like. Now, I'll be the first person to admit that being able to take control of Notepad, big deal. It's proof of concept. There's a lot of other scenarios in which you can corrupt the UI for a privileged or unprivileged application in such a way that you can take control of it and do something useful with it. So that's indirect execution. All right. Okay. Impersonating the user. You can use a Shatter attack to disable antivirus software. For example, 3 lines of code that will disable Norton Antivirus 2003. There's a number of ways of doing that, but who cares? 3 lines of code, how simple do you want it? You could even put it all in 1 line of code. What this does is it does a find window, so it finds a window called Norton Antivirus. It then finds a child window of that nav window that's got the caption disable. And it just so happens that nav has a hidden window, which you don't normally see, which has got a conveniently placed disable button. So we get a handle to that, and then we send a WM command message. Now, we could send a WM click message or WM left button click message to the button, but what happens is that gets translated into a WM command message and then sent to the parent window anyway. So we might as well just skip that step and go straight into WM command. So we send the parent Norton window, WM command, 3EB means I've clicked a button, handle it, and the final parameter is the button. And nav will quite happily just turn itself off. So if you've got a Trojan or something, it gets onto a user's machine, they don't know what they're doing, they double click the attachment, the first thing you can do is shatter your way into whatever antivirus software they're using and just turn it off. It's dead easy. You can do this for any antivirus software, any personal firewall, whatever you like. You can just completely impersonate the user. In fact, you can do it better than the user because you can programmatically access all of the hidden windows that the user can't normally access. Essentially, anything that the user can do, you can do programmatically. Some messages that you'll find are quite useful if you're trying to impersonate the user. WM sys command. If I select an item from a menu, from the system menu, so this menu here, that gets translated into a WM sys command message and sent to the application. If you run Spy++ from the Visual Studio suite, it'll allow you to monitor all these messages, see what the parameters are, so you can pick it all apart, see what messages are getting sent from what windows to what windows, just pull it apart. In this case, it's WM sys command. If you were to select it from a regular menu, it's a WM command. So you get a handle to the menu, you get a handle to the child menu, and then the item in the menu, and you just send the application WM sys command, and it quite happily treats it as though you've clicked the menu item. WM char is the message that gets sent when you press a button. So if you want to simulate someone hitting enter, WM char with the enter key parameters. Dead easy. WM left button up. This is useful if you want to simulate a mouse click. There's lots of different mouse messages. Left button up is probably the most useful one because you don't really want to be doing things programmatically when the user presses the button. You want to be done when they're finished pressing the button because then you know if they've dragged something, if they've dropped something in there, whatever. So left button up for a mouse click. Alternatively, you can do things the really easy way with a function called send input. What this function allows you to do is create an array of data structures which correspond to a keyboard or mouse event. So you can set up this whole sequence of events that take place, a load of keystrokes, whatever you like, mouse movements, call send input with that array, and that sequence of events is put into the input queue for the system. So it gets put in after the keyboard and mouse drivers have finished, but before the system actually handles them. So whatever you like, even if you can't be bothered to figure out how to navigate through menus or whatever, send input with the keystrokes, you're away. Manipulating the user interface. Again, anything that is possible programmatically, is possible remotely from another process. Some interesting messages, WM size, you can resize a window. You can change the no button on a dialog to be 1 pixel by 1 pixel. Try clicking that. WM move, so you can take the yes and no buttons in a dialog, swap them around. And then you can do WM set text to change the yes and no titles. How much fun would that be? Have you ever done that where you swap someone's mouse buttons around? Try swapping the yes and no buttons around. WM set text, play with the captions. You can even call create window. So you can create your own windows that are whatever structure you want, whatever window type you want, so you can create a button. It probably won't actually do anything, but you can create it. So you can take your dialog box that you want to mess with, remove the yes button, remove the no button, put your own yes and no buttons in there, which don't do anything, so the user has no option but to click cancel. So as far as they're concerned, it looks exactly the same as it should, but 2 out of the 3 buttons do absolutely nothing. Also, WM close. This is the message that's sent when a window is to be destroyed. Now, a window doesn't necessarily need to be a top-level parent window. It can be a child window. Your start button is a window. So I can send a WM close to your start button, and it will quite happily close. How are you going to do anything on your computer without a start button? You're going to have to kill Explorer, start again, and then if my code's still running, I'll just kill your start button again. You can have some quite good fun with it. Also, insert menu item. Not just windows, but menus as well. All of the system menus, all of the normal menus. You can do what you like with them. You can get handles to them, you can insert things into them, you can reset them to their default state, all sorts of things. So if you've got a pop-up dialog that just won't go away, you can reinitialize the system menu on that, which gives you a close button and a minimize button. So you can just minimize it, and the problem's gone. Again though, if you put a random menu item into another process's menu, chances are it's not going to do anything, because the target process will receive all those messages, but the handles it won't recognize, so it'll just ignore them. Okay, so you can completely manipulate the user interface, you can rebuild it from scratch. Why is this a problem? Well, it means that when a user is sat in front of a machine, they no longer have any guarantee that the user interface that they're seeing was actually generated by the application that they're using. Similarly, when the application interacts with its own interface, it no longer has any guarantee that that interface is the one that it created. So the user interface, those windows that you see on the screen, are no longer trusted by either the user or the application. There's something wrong here. Any security measure based on the GUI is trivially breakable. Let me show you what I mean here. I've got another proof of concept demo. Right, first off, little utility, very, very simple. All it does is it takes 2 parameters on the command line, a Windows Station /desktop parameter, and then a program name. And all it does is it creates it runs a create process call with that Windows Station and desktop specified and runs that process. So it allows you to start any process on any desktop, assuming you have sufficient privileges. So what I'm going to do here is I'm going to use this to start up a command shell on the WinLogon dialog. The WinLogon desktop. Now, in order to do this, I need local system privileges. So it's not a vulnerability, but it's proof of concept, and I'll show you what I mean. I have to do this through the task scheduler, because when you log off, the shell and all child processes that were created by it are terminated. So I have to do it through the task scheduler, because that's a different process tree and it will survive the log off. So, Well, it's 20 to 4, 20 to 5 in the UK. My laptop thinks it still is. So at 1740, so at 1740, run deskhack, which is this application here, and start cmd.exe on the WinLogon desktop. So I can now log off here. Right, and hopefully in a few seconds I should get a command shell popping up on there. In the meantime, let me show you the other application that I'm going to use now. Right, you'll notice on this screen, there we go, there's my command shell. You'll notice on this screen, I've set the system policy so that you cannot shut the machine down without first logging on. That shutdown button is disabled. So, what I've got here is an application that finds a window entitled Log On to Windows. Yeah, we've got one of them. Within that window, it tries to find a child window called Shut Down. Yep, we've got one of them. And then all it does is it calls Enable Window. Simple as that. So if I run this, run it, and the shutdown button is magically enabled. So in complete violation of the system policy, I can now shut the machine down without logging on. Now, this is not a security vulnerability because I needed administrator and then local system privileges to do this. However, this demonstrates one of a number of situations where a privilege is dependent upon the state of the graphical interface. Okay? If WinLogon was actually figuring out what the policy is and tracking it and completely ignoring that button, there wouldn't be a problem. As it is, WinLogon is trusting its own user interface, thinking that if the shutdown button's disabled, you can't click it, end of story. So it doesn't remove the functionality from that shutdown button. Okay? So, not a security vulnerability, it's proof of concept. Incidentally, while I'm here, you can actually start a shell on the WinLogon desktop. So, it's quite amusing. How many times have you ever seen that before? Of course, it's all running as local systems, so I can, have to be careful here. But it's quite good. And then if I exit this, it gets quite confusing sometimes when you're messing around with this stuff, because you log on and nothing changes. If I hit Control-Alt-Delete, I've still got a shell. It's very bizarre sometimes. It's quite amusing when you get stuck on a desktop and you can't get out of it. Okay, so any security measure based on the graphical interface is trivially breakable. Just change the interface. Do whatever you want with the interface to disable that protection mechanism. Oh, I'm giving you that example. Okay, so we can inject code into another process. We can then execute that code. We can take control of the GUI. We can modify the GUI at will. So what? It's all running as us. Well, obviously, attack goal number one is privilege escalation. If you've got a high-privileged window that's got an edit control, a tree view control, a list view control, anything like that, you've got a direct execution shatter attack, and you can just jump straight to your shellcode. If you've got any of the other window types, there might be a way of corrupting the GUI in such a way as to cause a buffer overflow or something like that. So if that process has got high privileges, you can steal them. On Windows 2000, there are a lot of local system windows. Some quick ways of bringing up a local system window. Net send 127.0.0.1 hello. Come on, ThinkPad. It's a net send. Anytime this week? Okay, well, when that comes up, the netsend window that pops up is actually owned by csrss.exe, which runs as local system. There we go. So if I now fire up Task Manager, you can see Messenger Service. If I right-click, go to Process. Okay, for some reason it's not listing it. I don't know. Whatever. That Messenger Service is running as local system. That's just one of many ways to do it. Another good way to do it is if a program crashes, you know the dialogue that you get saying this application is not responding, would you like to terminate it? Again, that's owned by CSRSS, it's running as local system. And even without that, there's a number of local system windows on default Win2K. XP is a lot better, but it still has things like the messenger service, the crash dialogue, stuff like that. Another good way to do it is if you call message box with the MB_service notify parameter. The whole idea is that this is a service which isn't allowed to interact with the desktop, but wants to pop up a message box on the desktop. So that actually gets marshaled into CSRSS, and it's that process that pops up that dialogue. So yet another way of getting a local system window. MSO2.071 is the original WM timer patch. It states, it's possible for a highly privileged process to coexist safely with less privileged processes on the interactive desktop. None of them could be subverted without the WM timer flaw. I disagree with that statement, and I think a lot of people at Microsoft do as well, because MSO3.025, privilege escalation in a utility manager. Right, let's show you some more code. Right, on Windows 2000, if I hit Windows U, I get the utility manager coming up. Now, this is running as local system. Now, this is actually a patched version of utility manager. I'll talk about that a little bit more later. This laptop, being a ThinkPad and hence intelligently designed, doesn't have a Windows key. So I can't demonstrate what happens when you press Windows U, unfortunately. So take my word for it, Utility Manager before this patch has a list view control. LV_sort items. Oh, we know how to exploit that. So what this code does, let me just close that now. What this does is, it does a number of things. Firstly, it counts how many command prompts there are open on the desktop, and it stores that. I'll get to why in a second. What it then does is, this shellcode is exactly the same shellcode as in smashing, but it's formatted, instead of to run this program again, it's formatted to run cmd.exe. What we then do is start Utility Manager. Now, you can actually do utilman/start if you're an administrator, or if you're a user, you have to hit Windows U. Unfortunately, I'm going to have to run this as an administrator because I don't have a Windows key. Take my word for it, take the code away, run it, you'll see that it works as a user. A good question. You can do send input for the Windows key, and the start menu will pop up. You can obviously do send input for the U key, and you'll get a U. Unfortunately, if you do Windows and then U, and then release U, and then release Windows, it doesn't work for some reason. Even the on-screen keyboard that you get, if you do Windows U on the on-screen keyboard, that doesn't work either. So, don't know quite what's going on there. I think it's being hooked by some other process, probably WinLogon, before anything else happens, so a little bit strange there.
What about the control and escape? Similar to it?
Control Escape is Windows key on its own, but you can't do Control Escape with another key. I've spent weeks trying to figure out how to do this. Okay, so we try and find a handle to the Utility Manager dialog. And if we find one, we come down here in the code. So we've got a handle to Utility Manager. We then send a message, we send a wide message to Utility Manager and put our shellcode in the window title for Utility Manager. We then get a handle to the list view control, and we send it LVM sort items address with a callback address that changes every time it's called. If we miss the callback address, we'll get a dialog popping up saying program error, because Utility Manager will crash. Doesn't have structured exception handling. So we keep checking for that program error dialog. If we find it, we send WM key down, WM char. Essentially, we simulate an enter key. So we clear that dialog, get it out of the way, and restart Utility Manager. So let me show you this in action. Yeah. Wake up, ThinkPad. No. Right, so if I now run this code, Utility Manager is popping up, or at least it would be if this ThinkPad wasn't completely messed up. Okay, Utility Manager is popping up here, but this exploit grabs the handle to it so quickly and screws it up so quickly that you never actually see it. It's not 100% reliable, but eventually we should. So you can see all these windows popping up. It's going fairly mental. And every time I run it, I seem to get a little closer. Trust me, on a decent machine, this works. Don't buy ThinkPads. Or at least don't buy old ThinkPads. Come on, are we going to get there this time? Okay, while that runs, you can take this away, you can run it. Okay, exploit failed. Don't know quite what's going on there. It does work. You'll have to just take my word for it. I don't like ThinkPads. Don't buy Presarios either, because they're just naff. Gee. Okay, so anyway, in principle at least, it is exploitable. This source code was working last night in the hotel room. I think it just doesn't like me. Okay, what else can you do with a Shatter attack? Well, you can make some very interesting Trojans and worms. I don't know how many of you remember like the good old days of viruses when they did things that were interesting, like make your screen melt and just randomly shake windows around and things like that. Combine that with a Shatter attack, you can do some great stuff, like swapping the yes and no buttons around, like anything that you want, instantly closing any window that pops up. How the hell are you going to do anything on a system if the moment you open a window, it gets closed? Scriptable user interface redesigner. A lot of applications nowadays seem to like being skinned, so you can completely rebuild the user interface. Well, I'm going to stand here today and say that you can do that with any application you choose. There's no reason why you can't write an application that will allow you to completely rebuild a user interface for another application, save that as a definition file, save it as a script file, and then the next time you run that application, you run the script, and the GUI gets redesigned to your specifications. We're actually working on this at NGS Software at the moment, but it's a fairly low priority, so don't expect it anytime soon. Essentially, it allows you to skin anything. So it's quite good fun playing with Word and making it look like Winamp. Okay, in a lot of situations, when you're programming, there's things that you can do with the user interface that you can't do from an API. An example of that is, at NGS, we were looking for an automated way to test SSL encryption on websites, see what levels they would accept. And we figured we had two ways to do this. We could either write our own SSL client or use OpenSSL and figure out the 400 million command line parameters for it. Or we could use Opera, because Opera allows you to specify what levels of SSL encryption it will accept. So we created a Shatter script that would automatically start Opera, navigate through the dialogues, check all the various levels of encryption that we wanted to test, and then fire up the website and see if it was accepted, read all the dialogues back, things like that. So it was quite easy. It didn't take very long. It took about an hour maybe. So we were using the user interface on Opera to do something that we couldn't do from an API. It's a great technique. It's very, very useful. You can automatically disable antivirus and personal firewall software. The moment that an antivirus program pops up and says, oh, this program looks like a virus, or oh, this program's trying to access the internet, you can just find the window, find the yes button, and click it. Where's the problem? Personal firewalls do actually have a slightly more severe problem than this. This is another exploit that I'm going to release right now, IE kill. This is virtually identical to the utility manager exploit, as you can see from the code. And I start it. Oh, I don't. The only thing that's changed really is that it doesn't count how many command prompts there are. Sorry. On the utility manager, the reason it has to count command prompts is because that's the way it figures out when it's successful. When you get an extra command prompt, it thinks, hey, I've worked. On this, we don't have to do that. What we do is we start Internet Explorer up, and then we do Alt F A through Windows messages, and this control right here is a list view control. So we can take over Internet Explorer. So what this does is it grabs a copy of Internet Explorer, runs through to get this dialog, injects the reverse shell code into the caption of that dialog, and then executes it through the list view control. Now, it doesn't work perfectly, so fingers crossed that it actually does something. Let me just start up a netcat shell here so I can receive it. Okay, IE kill 192.168.1. Oh, helps if I can type. Okay, so you can see Internet Explorer windows are popping up and crashing all over the place. Likewise with the utility manager vulnerability, there is a crash dialog that comes up there that we click OK on. Right, and you can see over here, I've now got a command prompt from this machine from Internet Explorer. So if Internet Explorer is trusted to access the internet, I've injected my shellcode into Internet Explorer. As far as the personal firewall is concerned, Internet Explorer is accessing the internet on port 80. Simple as that. I've not changed the signature of the binary, nothing like that. There's been no clues that a personal firewall would pick up that anything malicious has happened, yet I've got a command shell out of this box. You can do that with any code that you like. It could be a Trojan, it could be a DDoS agent, anything. I've actually tested this with Zone Alarm, with Tiny Personal Firewall, with Black Ice, a couple of others that I can't remember off the top of my head. Not one of them batted an eyelid. You saw that it was quite noisy, Internet Explorer windows popping up and being destroyed all over the place. It doesn't have to be. Any user on a Windows system, on a Windows 2000 system at least, can create a desktop. So you just create a desktop and you run your brute force against Internet Explorer on that desktop that you've just created. And even if a personal firewall does pick it up, you've got two choices. Firstly, you can shatter your way into the personal firewall and click the OK button, or you can trust the user, because if you see that you've got no Internet Explorer windows open, you know about this thing called Windows Update, you're not entirely sure what it does in the background, and you see Internet Explorer is accessing the internet, do you want to allow it? You just click yes. So there's a lot of possibilities there, and unfortunately there's not a whole lot that the personal firewall vendors can do about it. Now this code at the moment is built for IE6. It's trivially portable to IE5, Opera, Netscape, AOL, whatever you want to do. Any application that is trusted by a personal firewall, you can shatter your way into it and get it to access the internet for you. Yeah?
Can you do it
Sorry, say that again.
If you could do it by creating the Internet Explorer, rather than the window appears,
You can do that, yes. You can create the window as a hidden window. You're absolutely right. Another way to do it. It's not spawning off multiple times. Every time that you attempt the brute force, if you miss the callback address, Internet Explorer crashes. And then, you know the dialogue that you get, would you like to restart Internet Explorer? It just checks, makes sure that that button's checked, and then IE dies and starts itself up again for you. So that's IE kill. All of this source code is in the bundle that you'll be able to download from the NGS website 24, 48 hours from now. Okay, let's look at ways that we can fix these things. Currently, the Win32 API does not allow these to be globally fixed. I'm going to say that. I'm sure that there's people that will disagree with me, but I do not believe that you can globally fix these problems. The two ways that you could do them is by firstly changing the architecture of Windows very slightly, or making an addition to the Win32 API. We'll talk about them in more detail now. Whichever solution you choose, chances are applications that run on Windows are going to need recoding. At the very least, they'll need recompiling. There is no easy fix. I want to just leave Win32 alone for a moment and see how X11 does it, because X11 is better when it comes to these kind of attacks. So just to give you a feel for why Windows is not handling this stuff correctly, and a better solution for it. In X11, a message is a notification, not a command. It's saying to the application, the user has pressed a button, or this mouse button has been clicked. It's not saying, add an item to a list box. It's not saying move. It's not saying close. So it's just a notification. It's not a command. X11 messages also have a flag in them called send event. This identifies whether the message was sent synthetically or whether it was sent from an application. Or whether it's sent from the X server itself. So you have effectively routing information. You can tell whether it's a genuine message or not. You can globally filter these send event messages. So you can just globally disable cross-process messaging. It's not perfect. It has its own problems. You can layer transparent windows on top of other windows, capture all the input for them, things like that. It does have some good points, though. Okay, architectural changes. You could just globally prevent cross-process GDI messages. You could even ACL it. You could say, add a privilege to Windows saying, this user is allowed to send messages between processes. At that point, it comes down to the administrator to decide what's good, what's not, what he's going to trust, what he's not. The problem with that is that there's a lot of software that's going to break. Things like PGP, when you do current window decrypt, that uses cross-process GDI messages to retrieve that text. Things like automated software testing tools already use some of these techniques to navigate GUIs. They're all going to break. Accessibility tools, things that make the screen bigger, things that provide keyboard input, things like that, they're all going to break as well. So chances are it's not a complete solution. You could extend getMessage to getMessage EX. The Win32 API has a very long history of being extended through these EX functions. The new structure would contain source information about the message, which might be a process ID, it might be just a flag saying whether it's synthetic or whether it's from the server. Whichever way it would be implemented, it was then up to the application to decide what to do with those messages because it's got the information to decide where that message came from. It wouldn't break any existing software, but it would have to, go back, Chris. It wouldn't break existing software because it's just another call. Application developers would have to recode to use this getMessageEX function. Problems with these two solutions. As I've mentioned, any change to the Win32 architecture is going to break a lot of stuff. You can't do it lightly. If you extend the API with a new call, you're going to have to rework the software to actually use those new calls. So anyone that doesn't is still going to be vulnerable. The way that things are going at the moment, issue by issue, it's not working. It's going to be one of these problems that is endless. There's always going to be new messages that people find, new techniques that people find to take advantage of these things. Another big problem is that the GDI functionality is absolutely core to the way that Windows works. It's rather old as well, and I'm willing to bet that there's been not much coding done on it in the time since it was first released and nowadays, purely because it is so fundamental to everything that Windows does that you wouldn't want to touch it for fear of introducing a bug. So if the kernel, which is responsible for marshalling these messages between processes, if the kernel doesn't actually know itself where these messages are coming from, if the structure that internally is used for a message doesn't have space for a message source, you're fairly screwed. Because if the kernel can't keep track of where a message is coming from, how are you supposed to pass that information along to an application? Entirely possible that that's the case. So, just to sum up the important points, if you've got a window with a tree view, an edit box, multi-line or single line, a list view or a rich edit control, you can trivially exploit it with a direct execution shatter attack. There are other controls that are vulnerable. This is just a random sampling of them. Users cannot trust their user interfaces. The trust between the user and the application is broken. And you can do a lot more with these things than just escalate privileges. It's fun. Try it. Okay, questions? Anyone? Sir? To be honest, I haven't played with any other messaging systems on Windows. I've been having too much fun with the Win32 API. Anyone else? Yeah.
What about these, I said, Paget, I think you saw it, but you don't serve it. It's with the message, but overrides the
Yes. When you send messages between applications, there's a lot of messages that accept pointers to data. Now, that data is usually marshaled between processes. There's a paper just been published recently. I can't for the life of me remember who wrote it, but they claim to have found a message where that data is not correctly marshaled between processes. So the pointer is not changed. So what you can do is you can overwrite the memory space of a target process using GDI messages, inject your shellcode. I think they can inject it 4D words at a time to a known location, and then overwrite structured exception handling, the unfiltered exception handler, next exception that goes off, bang, your shellcode's there. So that's a third technique, yes. Yes? XP in 2003 are fundamentally the same as NT, purely because they're all based, they're all Win32. XP in 2003, it's more difficult to get a local system window, but there are still ways of doing it. Sir? I haven't looked at the GTK stuff, no. I've had some quite long conversations with Alan Cox over email. He corrected a few X11 details in my original paper. So I've not played with it. I've not played with any of the other messaging systems. As I say, I've been having too much fun with Win32. Anyone else? Great. Thanks very much.